This is Euclid Book 10, proposition number 68. A straight line commensurable with a major straight line is itself also major. Let AB be a major line, and let CD be commensurable with AB. This is commensurable with this. I say that CD is major. Let AB be divided at E. Therefore, AE, EB, those two lines there, see this one here and this one here, they are straight lines incommensurable in square, which makes the sum of the squares on them rational. So if you add these two areas together, you'll get a rational area. But the rectangle contained by them is medial. This area is medial, the sum of these two is rational. This is by Euclid Book 10, proposition number 39. Let the same construction be made as before. Then, since as AB is to CD, as this line is to this line, so is AE to CF, as this line is to this line, another ratio. We're going to be doing ratios, so pay attention to what I'm saying here and write down the ratios. Okay? Let's do this again. As this is to this, so as this line is to this line. And as this is to this, so as this is to that. Therefore also, as AE is to CF, so is EB to FD. We've already established that. This is by Euclid Book 5, proposition number 2. But AB is commensurable with CD. Therefore, AE is commensurable with CF and EB is commensurable with FD. And since, as AE is CF, as this is to this, and this is to this, alternately also, as this is to this, as this is to this, so as this is to that. Alright. This is by Euclid Book 5, proposition number 16. Therefore also componendo. Okay. As this whole line here is to this short line, whole line to the short line, so is this to this. This is by Euclid Book 10, proposition, not 10, Euclid Book 5, proposition number 18. Therefore also, as the square on as the square on AB, which we did not draw, let's draw a square on AB. There's your square on AB. Okay. As this is to this, so is to this. Okay? So as this is to this, so as this is to this. If you want to read it out to you, that's fine. As AB is to EB, which these are squares, as this area here is to this area here, so is this area here to this area here. Okay. This is by Euclid Book 6, proposition number 20. Similarly, we can prove that as the square on AB, which is this one right here, is to the square on AE, so also the square on CD is to the square on CF. Okay. Therefore also, as the square on AB is to the square on AE and EB, so as this is, now what you have to do here is you have to add this area together and you add these two areas together. Okay, you're going to add these two areas together. As this sum is to this, or actually the ratio goes like this. As this is to this sum, okay, so is this to the sum of this and this. You add these two together and this is to that sum. Therefore also alternately, as this is to this, so is the sum of these two to the sum of these two. Okay? That's by Euclid Book 5, proposition number 16. But the square on AB is commensurable with the square on CD. So these are commensurable areas. Therefore, the squares... Now, what you do is you add these two areas together. When you add these two together, that sum becomes commensurable with the sum of this and this. You add these two together, you add these two together. That sum and that sum are the same, commensurable. Okay. And the squares on AB and EB together are rational. So if you add this sum, the sum is rational. Therefore, the sum of this and this together is rational. Similarly also, twice the rectangle AEEB. So what you're going to do is you're going to take this area, you're going to take this area and you're going to multiply it by 2. And you're going to take this area and you're going to multiply it by 2. So twice of this is commensurable with twice of this. And twice the rectangle AEEB is medial. So twice of this is medial. So twice of this is also medial. And this is by Euclid Book 10, proposition number 23, porism. Therefore, the lines CF and FD are straight lines incommensurable and square, which make at the same time the sum of the squares on them rational, for the rectangle contained by them medial. Therefore, the whole CD is the irrational straight line called a major. This is by Euclid Book 10, proposition number 39. Therefore, a straight line commensurable with the major straight line is major. Wow. Alright, that's the proof. I will tell you more in a future video. Stay tuned.